Hey y'all, welcome back. Thanks for joining the channel. Good to see you again. Hope you're all well. So this is a familiar face for some of you. You saw me post a little teaser video on this one. This is the DX-150B from Realistic. Yeah, I want to do a restoration on this one because I plan on using it for a while before I pass it on to a new owner. This video is going to be the repair. Now this is already working. We tested it. We were picking up shortwave from out in the ocean, and it is working, but not completely. Not all the bands are working. The band spread is all mucked up here. This is all damaged. I don't even know if it's complete. It might be missing parts, but we'll get on that and clean it up. Mostly it's just cleanup. Look how filthy it is. And yeah, we'll get this thing started on. So let's do this. Now, it came with a speaker. The speaker has the 1/4-inch jack. I have a feeling this wire is broken inside somewhere because when you have to move it to get it to connect when you're using it. Let me show you. I'll plug it in here and we'll see how this goes. Yeah, it's mostly cleaning. Okay, so we're turned off right now. We're drawing 3/4 of a watt on our meter. So the transformer is always on, always alive. Turning it on. Jumps up to about 2.1 watts. Where is our plug? See how turn up the volume. So we might have broken conductors in here. I'm not sure. Or it might be on this side. Or it could be just a dirty jack and plug. So we'll get on that. Alright. So let's open it up and have a look inside. Alright, screws are out and we're going in. There we go. Oh, it looks very nice. So here's our main PCB board. It has a good layer of dust on it. This has the B version receiver has the NEC UPC 20 or 200 chip, audio amplifier chip, and it's all support circuitry. This to a C1173 looks like a voltage regulator of some kind. There's a Zener diode down here below it. Power supply looks pretty crude. Everything looks okay with dial strings. Dial strings are all here and it's seized up. Interesting. Here's our disc. If I can get that disc out. You can't even see it. You can see our disc here. Oh, you're kidding me. Okay, there's our band spread disc. So that came unglued, which isn't too bad of a thing. We can actually just glue it back onto the wheel here. But nothing's turning. I think everything's seized up. It's quite stiff. So you can see the lubrication, I think, here is quite stiff because this, oh there, now it's going. Yeah, this all has to be relubricated. This one needs to be relubricated. This one's working a lot better though. We'll have to reglue this disc. Okay, there are a couple screws missing on the bottom and the other ones look like they've been used, well used. So somebody's been in here a few times. Looks like somebody's looks pretty good. Looks pretty good. Here's our band switch. That's where I think we're going to need some cleaning on these three wafer switches here. It looks like somebody's been soldering on this, but I think it's all factory, to tell you the truth. I don't think anything's been mucked around with, even though somebody's been in here many times. I don't know why they would come in the bottom like that. Yeah, so I opened it up and I'm greeted with all these lovely smells again. And I pulled the front panel off. You can see how dirty this thing is. It's pretty gross. I don't know if yeah, it's pretty nasty. So I'm going to do some cleaning here first. And then we'll work on this band spread indicator here. I'm going to have to figure out how to glue that back on. Yeah, it's actually fairly clean inside. There's no dirt or dust because the only ventilation is these holes at the back. There's not that much dust. But let's see, we're going to give it a full recap. We're going to do that much for it at least. What are these capacitors? These are Marcon? Yeah, the Radio Shack caps are not the greatest. So let me get started cleaning and recapping. I'm just taking some measurements of the power supply hum here, and I'm measuring off the collector of what is this, Q11, and here's a look. So I got 200 millivolts division. I got about, oh, what is it? Let's see. Go down. That's about 300 millivolts peak to peak of ripple there. Let me try on the other, what is this, the emitter? I think that's the emitter. Is this the base? Or is that the emitter? Still, we're getting a good 50 millivolts there. And on the other one, same thing. This is across the Zener. There is, let's see, that's the ground side of the Zener, and that's the other side. Getting ripple all through this thing. So I'm going to see if I can improve that ripple with some better caps. Okay, so what's the point of having a regular power supply if it's just going to pass hum? You hear this hum? Let me turn up the volume. I'm just going to add some capacitance here on these filters and see if we can get to silence up. Where are we? In here? Yeah. That's 1,000 microfarad I'm adding. Quiets it down quite a bit. And there's another one here. Where is it? It is 73. 73 is back here. Let's try this one. That one doesn't make any difference. So the hum is coming from, could be a ground loop too, the way the circuit's laid out, because I'm adding capacitance right here. And it actually makes it louder right at the end of the regulator before it hits the circuits. There's a capacitor, 470 at 16. I added 1000, hum got louder. So that tells me we got a ground loop somewhere within this power supply that's inducing some hum somewhere. Let's try, what's this other cap here? C70, no, that's not the one, 71. There's 3 caps here. C33, where is C33? Okay, here it is, it's on full volume. And the hum is gone. And I'll tell you what I did. Turn that off. Yeah, the hum is very, very quiet now. So I took a look at this circuit, and they have 2 capacitors here. It kind of defeats the purpose. Here you got your power coming in. There's your bulk capacitor. It's a 470 and 16. I upsized this one to 1000 and the hum went down, but that was just a test. I haven't changed this one yet. And then it goes through a 0.47 ohm resistor, and then it goes to the series pass transistor, and then on the output there's another 470 at 16 volts. I added a capacitor across this one, and the hum actually got louder, believe it or not. Okay, so we're on the wrong track there. Add capacitance here, it goes quieter. Add capacitance here, it goes louder. So what's going on with this circuit? We have a 10 volt Zener going, setting up the bias for this regulator. We have a capacitor here and a capacitor here between ground and rail voltage, let's call it. And then there's a 470 ohm resistor. Now I took a capacitor and bridged it across this one just as a test, and it really didn't make much difference. It went a little bit quieter, but not worth even noticing. So that's a 47 at 16. So what I did is I removed this cap and I replaced it with a 100 at 116 volt. Okay. Next thing I did is I removed this cap entirely. This one's out. And just with these 2 modifications, this is how quiet it is. It's full volume. I hear a hiss. There's the RF gain turned up. AF gain. I don't have any tuning going on here, but you get the idea. So my next step is to replace this one with a 1000 16 volt. This one will stay at a 470. This one's gone completely from the circuit, and that should be our regulator. It should provide clean DC to the radio, and that's what I'm going to go with. So next I'm going to change the main bulk filter cap. This is 1000 at 16. And there it is with the 1000 microfarad cap in, and I can hear a tiny bit of hum. I think that's coming from the audio amplifier though. So you're probably wondering, how can you make the hum go away by removing a cap? Shouldn't the caps be in here to eliminate hum? Well, yes. This cap here between ground and the positive pin of this Zener diode, that's to keep the Zener diode in check and to keep noise off from the Zener diode getting into the transistor. But this cap here between the B plus rail and the base of the transistor is actually coupling any hum into that transistor. Any hum that's coming on this line goes through this cap easy, and it is deposited onto this base. any hum that's put on this base is going to be actually amplified and put onto the DC, the regulated DC out. So that cap shouldn't have been there from the factory. They should never have put that cap there, because all it's doing is coupling the hum from the AC to the input of the transistor. So I eliminated that, the hum went away. Now it's debatable, did I need to put this at 100 microfarad? No, I could have probably left it at 47. There's really no harm in leaving it at 100 or 47. It's there just to cut the noise from the Zener diode down. And then there's a bulk capacitor after the regulator. So I'll go replace this one next. There's no advantage in getting a large cap here, I don't think. So I'll just replace it in kind with a 470 at 16 volts. It's also funny to note that that cap that I removed it was right here, and there's no silkscreen on the board for it. It was just 2 holes drilled, the legs went through, and they tacked the legs to the circuit. Yeah, I think it was an afterthought on somebody's part. I think they were trying to fix something, but they made the hum worse. But it's done now. So now that we got the hum problem fixed, I'm going to go through and replace all the rest of these caps. These caps are getting pretty tired. They are measuring way high in value. For example, this is a 470 at 16 volts. And if I measure it right now, it's going to measure back at 60 microfarads, which is way out of tolerance. 1.2 ohms ESR, which isn't too bad, I guess, but it's probably very leaky, these caps. These are old, and just as old as the unit, so time for some new ones. Okay, the recapping's done. That went well. Gotta say, these caps were really out of tolerance, the originals. Anywhere from 25 to 45% out of tolerance. So yeah, this is a good thing, replacing them. There was only 18 caps in this thing, so it wasn't that difficult. You got to be careful with the board. The board is really touchy to heat, so you'll lift a pad easily if you're not careful. And I did lift a couple pads, but you know, you can repair that by laying the lead down and soldering it, and it holds it in place. Now I'm going to focus my attention on mechanicals here. I'm going to get, this needs to be lubricated. I'm going to lubricate a lot of this stuff. It's pretty crusty over the years. So I'm going to remove this black background for the dial face. And it's pretty simple. 2 screws on each side. You loosen 2 screws here and the meter just comes right out. And you got to remove the bulbs. They're just pressed into a grommet. And then the whole thing will come, the string will hang. And then I can do the service for all this. I can re-glue my disc. I'm going to clean this up and re-glue it onto the band spread tuner, which is freed up now that I've been playing with it. But it still needs relubing. You know, I want to take this all apart and relube all the controls, just so it's really smooth when you're using it and not crusty and dried up. You know, the more I twiddle with them, the freer it becomes. But that old grease is still there, and if you let this thing sit for any amount of time, it'll seize up again. So I'm going to get on that. Let's remove this. Okay, I went through and lubricated all the rotating parts here. These shafts, you remove the E-clip on the back side, and it allows you to pull the shaft out probably about ½ inch or so without disturbing the dial cord at all. You can pull it out, clean the old grease off, and then re-lubricate it, put it back together, and put the E-clip back on, and it seems to work. This one too. I did the same for this one. This one has a counterweight on it, or a flywheel I should say. So you just loosen the 2 screws on the flywheel, and the flywheel falls out of the way, and then you can pull the shaft out and clean and relube, just like this one. This capacitor, I lubricated the bearings. So I'm at the point now where I need to glue this disc back on, and I mixed up some 2-part epoxy here. Should be enough. I just need a small drop. So I don't know if there's any aligning this. Put this on here. It's just pressed onto a collar and glued on. So I have to align this like so. The band spread. Alright, I think that's going to be easy enough. I don't think I have to do anything fancy. Let's just goop it up with some epoxy. And I cleaned the old adhesive off here, and I cleaned the old adhesive off here and cleaned this with alcohol. You always clean with alcohol before you epoxy. Otherwise you risk the epoxy not sticking. So I'm just going to give this a small amount. I don't want to get crazy with large amounts of epoxy here. So I'll put this on. And then you need to rotate this. Right about there, I think. Also need to make sure it's on seated. Alright, I think that's good. We're going to let that set up. Make sure it's on. And I can see on the back side the epoxy's all working. Okay, I'll let that set up and then I'll come back to it. I also lubricated the bearings on these 4 variable air capacitors. You can inject a little bit of the grease into the bearing where the ball bearings are. That helps a lot. Gives it a little smoother feel. The thing about a shortwave radio is all about the feel of the controls. It's not how well it performs, it's also the feel of the controls, because if you're working with this radio, you're sitting here all night long, you're twisting and fiddling with these controls. You want them to be smooth and silky, and you want everything to work good. But you also want it to feel good too when you're operating it. So that's the reason I go through and lubricate everything. Even these pulleys on the tops corners here, they get a shot of grease, so it becomes effortless to turn these knobs. And make sure that they're working good. Okay, I'm going to let that set up, and then I can start reassembling, put the dial face back on, and we can clean that. This needs to be cleaned. It's got filth on it and dust, so I'll give this a scrub, and then we'll put this back, start putting this back together. So one more thing I want to make note of with these dial strings and tuning dials is if the string is loose at all, you see it's got a bit of a, this spring should be keeping it under tension, but this spring's collapsed and it's really not doing anything here. It's just barely keeping tension. This one here as well. This one has a little bit of tension on it, but not much. What you can do is you can disconnect this spring and then cut one turn off and then spread out the last turn to make another hook, and that shortens your spring, and in effect it kind of gives it a little more tension. You see here we're right at the bottom of the tension. It's really not doing anything, that spring, but it's not slipping as well. So if it starts slipping, you can fix it just by shortening this spring or shortening this spring. Alright, now I think we're ready for alignment. I think we're all done with the work. So what I've done is here I'll show you. They specify in the service manual to connect a 50 picofarad capacitor to tuning capacitor 4, which is the center one, and that's what you connect your signal generator to. Signal generator, 50p, cap, tuning capacitor, and then the other side I have grounded to the chassis. I'm feeding it a 455 kilocycles signal with AM modulation, and our amplitude is way down at the bottom right now. So what I'm going to do is I'm going to turn up the amplitude on the signal generator, and then we're going to peak this coil, this coil, this coil. This is T1, T2, T3. We're going to peak that so that we get maximum deflection on our meter. Let me start here. We'll zoom in. I'll zoom in on the meter so you guys can see it, and then we'll start turning up the signal on the signal generator until we get turn down the volume of the... Okay. Let me adjust this so we have a little bit more on the meter. Right about there, let's say. Okay, turn down the noise. And let me start, if I can find a screwdriver, start on T1. So here we go. That's probably the peak for T1. Came up a little bit. T2. Oh, there's a little bit of gain there too. Let me turn down the signal a bit. And T3. So they were off peak just a bit, but we did get some gain from that. So I'm just peaking it right now. Right there is good. Let me go through one more time. That's as good as it's going to get. PT2. Same thing. And then T3. Okay, we're on. So we did gain a couple of S units, 1.5 maybe. So that's good. So that's it for the IF adjustment. Okay, next up we're going to do the oscillator coils and adjustments. So these are all our adjustment points, and these are for which band? A, B, C, D, and these are our adjustments. So we're going to adjust, it says here, make oscillator adjustments first, then RF adjustments to obtain maximum amplitude, adjust antenna last. So these are our oscillator adjustments, okay, for low end of the band, high end of the band. I'll just put low, high. And then our RF adjustments are here. And then we do these last. So it's 1, 2, and 3. So we're going to start with band A on this. So we got L9 TC5. So these are our oscillator adjustments. Here's L9 TC5. And then I believe this is L10 TC6, L7 TC11, no, TC7, L11 TC7, L12 TC8. So these are your oscillator adjustments, these 8 adjustments here. So we're going to do that first, and we're going to use the S meter again. I changed to a loop antenna. So let's put this on 600. And then let's adjust it for maximum. That is not the modulation I'm giving it though. Okay, right here. I'm going to leave it there as maximum. So turn off the modulation. I'm still getting a tone. Coming in fairly strong. There's our tone. Okay, let me peek this one more time here. Okay. Now we'll do the high end of the band. We'll go to 1400. And then the signal generator is set for 1.4 megahertz. Got a strong signal, and we got modulation. So that's what's going in. We're set to 1400 on the dial. Let's dial in our oscillator. It's not there. I'm not picking it up at all. Okay, I'm quite a bit out at the top of the band here. I'm going to set this to 1400 right now, and then I'm going to go up on the frequency on the generator. We're going to see where it locks in. Okay, here we go. Right there. And I'm at 1.3 megahertz. So we're 100 kilohertz out. So that's obviously something wrong there. And I've got the adjustment pretty much backed out all the way. So we have a capacitor that's out of tolerance or something that's wrong in this circuit. So let's check into that. Okay, I think I know the problem. I had the band spread set to the wrong end of the band. They said to minimum, and I assumed that was minimum frequency. So if I looked at the thing, this is at maximum frequency right now. It's on the high end of the band. If I turn it down, it made sense to me as a minimum here. But the plates are fully meshed, so that's maximum on the capacitor. So if I turn it away from maximum and set it here, this is minimum, the plates. And with that, I can pull in the station or the signal generator with adjusting the slugs. So I'll put this on 1400, turn up the volume a little so we can hear it, and then start cranking in this tuning capacitor. Okay, there we are. Alright. So let me peek this one out. Okay, I'll go back and I'll do the 600 one more time. Back and forth, just to make sure that this band is good. Okay, we're pretty close. We're pretty close. It drifted a little bit. So let's go and peek this one more time. wow. Okay, turn this down. Okay, that's peaked. Now I'll check 1400 one more time. Okay, 1400. We should be here, hearing something. Let's try adjusting this a bit. Bring it in. Where did it go? Oh, there it is. Okay, we're peaked there. Let's try it. I'm going to go back and do 600 one more time. And we should be right on. And we are. Okay. Let's go to the next band. Band B. Okay, we're on band B, 1.7 megahertz, which would be this tick right here, because we got 155, 16, 17, 18. I'm going to leave it right here, and then we'll see where our signal is. Start adjusting our slug on, I think it's TC10, or no, coil 10, L10. There it is. Wasn't far out. It's not coming in very good. I'm going to redo the antenna connection. Okay, I'm feeding it directly into the back antenna, so we got a better signal here now. And using a lot less RF power to bring up the meter. So let's tweak this one more time. I just knocked it out of. Okay, good. Now we're going to do top end of the band, which is 4 megahertz. 4 megahertz should be right here. Okay, signal generator is at 4 megahertz. Let's adjust tuning capacitor. Here we go. Okay, let me turn the strength down. Peak this one more time. There. 4 megahertz. Well, a little bit out. It's very, very selective. This capacitor is dirty or something. I'm trying to get it peaked here. Okay, we'll leave it at that. You can check it in the middle of the band at 3 megahertz. Let's go to 3 megahertz. Let's set the generator 3 megahertz. And where's our signal? It's there. See how touchy it is with the tuning? Okay, next band, C. And we're going for 5 megahertz on band C. I don't have it hear anything on band C. And let's set this up for 5 megahertz. Turn down the volume. RF gain is up. Okay. 5 megahertz. Let's see if we can find 5 megahertz here. We might have a dead band. I don't hear anything. Let me turn up the volume of the generator. That's a fairly strong signal, and we are not picking anything up on band C. Nothing at all, so we have to troubleshoot band C. Alright, here's the oscillator circuit for the radio, and it's all handled by this 2SK19 FET here, Q8. What they have is they have power coming in here. They got a bulk filter cap, 470 microfarad at 16 volts. And then they have a diode, Zener diode. There's a dropping resistor, Zener diode. So what they're doing is they're doing regulation, local regulation for this, so it's keep the circuit stable. Anyways, we're not talking about that. We know this is working because we have band A and band B working, but when we come to band C, it does not work. And we never checked band D, but I think band D works because when I did the initial video a couple months ago, we picked up a station on band D. I think it was at 15 megahertz. So band D should be working as well, but band C is not. So this one's working, and this one's assumed working, this one's not. So our problem is probably isolated in this little area here between this switch and this switch. Could be switch contacts, could be a bad capacitor, could be an open coil, could be a lot of things that are going on here in the band C. So we're gonna have to go through and check. It narrows it down quite a bit. So it should be pretty easy to find, I think. So let's have a look. Okay, so what I did first is I went through and cleaned these wafer switches. There's 3 here, there's 2 on each one. So there's 6 switches in total, but there's 3 wafers. And they were quite dirty with the black silver corrosion. And I used 401B as a cleaner on a cotton swab and just went through and it removed a lot of the black oxides. But I also see something here that might be a problem. Let me zoom in and I'll show you if I can get it. I don't know if you can see this. This capacitor here, it looks like it's touching on this lug underneath. You can see the lug. There's a lug up top here, and then there's a lug down below, and it looks like this lead is shorted. Let me turn the radio on. Looks like we might have our band back. Am I in C? Yeah, I'm still in C. Let me manipulate this. I don't know. But we do have band C back, so maybe cleaning the switch helped. But I think that was shorted there, to tell you the truth. But let's get back to our alignment. Alright, let's get back on track with our alignment. So I got my signal generator set for 5 megahertz AM. Let's see what we got here. Oh, there it is. I think that is bang on. Don't get any closer than that. It's right on the mark. Okay. Now let's go over to 12 megahertz and we'll check up there. 12 megahertz. Right there. Okay, so we have oh, we're ever so close. Okay, so I'll set this to 12. And we'll adjust the trimmer. Increase the amplitude a bit just so I got a bit of, and then we'll adjust this so it's bang on. Looks like we're getting several peaks. I'm getting 1, 2, 3. I wonder why that is. As I tune through, I'm getting several peaks. It's very selective, very touchy. I'll try and get it close. Right there, I think. Okay, I'll leave it at that. And let's check the center of the band at 8 megahertz. There's 8 megahertz right there. Let me set the generator. Bang, there it is. We're on. How come we're getting such a strong signal here? Turn this down a bit. Let's go back to 12. Here's 12. Getting much of a signal at 12. It's very weak. I don't like that. I don't know why we get such a strong signal at 8 megahertz and such a weak signal at 12. There's something wrong there. It shouldn't be like that. Let's go back to 8. You see how strong it is there. Antenna trim. Let's go to 9. Okay. This is a little weaker. Let's go to 10. Turn that off. That's probably the biggest part of my problem is the noise. Let's go to 10. $11. And 12. Let's try 12 again. Just gets weaker as it gets up the band. Let's try 13. Completely gone. Where did it go? It's gone. Where did it go? What's it picking up there at 12? Let's go back to 12. I'm coming down on frequency. $12.1. There it is. Let's go up to 12.1. 12.2. 12.3. 12.4. 12.5. 0.6. 0.7. 0.8. How come there's no 13? Nothing. This is crazy. It seems like after 12.8, 12.9, it just drops and there's no reception. That's really weird. There's 12.9. .91, 92, 93, 94, 9.5 is off the band. 9.4 is the last frequency. So this end of the band is really inaccurate. That might be, and we might have to adjust for that. So let me go with 13. Let's try band D. Okay. We are quite a bit out here, so let's adjust band D. Okay, we're on band D, and I got this adjusted to 13 megahertz. And we are going to watch the S meter, and I'm going to adjust. Let me see if I can. We're going to adjust this one here. This is for D. Let's see if we can bring in D. Just barely there. Turn up the amplitude a bit, and then maybe we can get a better. Right there is the peak, 3.5. Okay, so if I can get this to rest on there, we should be good. Now we need 28 megahertz. Right there. Let's see, 28. Okay, going up in frequency. And we're going to adjust the capacitor trimmer. There it is. Okay. Right there, I think, is peak. I think that's it right there. Okay. Let's check center of the band at 21. 21 megahertz. A little bit out. Let's go down to 14 again. Go down to 14. Make sure 14 is correct. There's a 14. Let's go back to 14. fairly strong signal here. Yeah, we're out a bit. So let's adjust for the coil again. Is that it? I hope so. 14, let's go 28. And we're off a bit here too. So let's tweak this one. That's pretty close. Let's see here. Okay, check 21. Check 14. Good. So we're gonna leave it at that. Okay, so what we just completed was the first step was the oscillator adjustments. And that's what trims up the oscillator for the dial scale to make your dial scale accurate with the world. So we tried to get it as close as possible. This is the low end of the band, this is the high. And we went back and forth a few times on some of these to get them to match up. So the dial accuracy of this should be very, very close. Now we're going to go on to the RF stage, and we're going to peak for maximum signal, and we're going to do L5, 6, 7, and 8 on the low end of the band for band A, B, and C, D, and we're going to do trimmer capacitor 1, 2, 3, and 4 for the high end of the band. Same thing, but we're looking for maximum deflection on the S meter. We already done the accuracy, so we're just going to tune the receiver to the signal generator now, so we get maximum signal. Then we go ahead and do our adjustments. Okay, so I'm pumping a fairly large signal into this thing, and I think this is our first trimmer. We're just peaking this, and it's peaking right there. Turn down the signal. Try this again. Yeah, that's as high as we can get with this trimmer, this coil. Okay. And we also want to trim L1 for the antenna stage. Let's see if we can peak this out. Okay, and then get L1. L1 is the big loop stick antenna in the back here. And I did have it peaked. Okay, I'll leave it there. Need to get some wax to seal that. Let's go to 1400 kilohertz. 1400 is right here. Okay, so we're at 1400. I'm getting terrible reception at 1400. go. That's better. Let me turn down the signal. A lot of background noise. Okay. Wow. Okay, I'll leave it at that. Okay, moving on to band B, we're going to do 1.7 megahertz first. Where is 1.7 again? Right here. Okay, and we're going to do L2, I believe. Wow, look at the crazy gains we're getting. Let me turn some of this down. I hit the wrong one. I just adjusted the wrong one. I have to go back and redo band A. I'm going to leave it right there. That's pretty good. Top end of the band is 4 megahertz. 4 megahertz. Okay, let's do a trimmer capacitor. Wow, see how far out it was. Quite a bit out. And turn down the signal. Yeah, it's going to be peaking really nice there. This thing's going to be a hot receiver. Okay, 1.7 again. Let's try that. Right there. Back to 4 megahertz. Okay, trimmer capacitor. It's crazy. Wow, sensitivity this thing has when it's tuned. Okay, let's go to band C. And we'll start with 5 megahertz. Okay. Let's see what we get here. Get locked in on the slug. There we go. It's not turning. What's going on? Okay. Creases a little bit. Let me get some more signal. I'm down at negative 100 dB. Let's go to negative 90. And this should be able to peak this pretty good. Okay, let's do the high end of the band. 12 megahertz. This is the one we were having troubles with, 12 megahertz. Turning up the signal a bit too. A little bit out, not bad. Okay, trimmer capacitor. There we go. That opened it up. Turn it back down to negative 100. Let's peak this. Okay, I think we're good there. Let's do band D now. Start at 14 megahertz. Okay. A little bit off peak, so we got it back on now. Right there, I think. Yeah, right there. We just about got 2 bars. 1 and 3/4. Let's do 28 megahertz. Okay, here we go, tuning capacitor. Oh, it was cranked right down tight. There we go. So we can get 7.5 out of this. See if I can get it peaked right there. Let's check 14 again. Don't know if we'll get any more out of this. Oh, we did. Got it up to 3. 2.5. 3. Right there. All right. Back to check 28 one more time. There we go. No, we get 5.5 maybe. 6, about the best we can do. Okay. That's not good. How come it's changing? Very touchy. There we go. Okay, so we just finished adjusting and aligning the RF stage, and this brought in a lot of gain, especially on the high end of the band for sensitivity. So now our last one is to do the antenna stage. Basically, you're adjusting L1, L2, L3, L4 for the band, and VC1 is your antenna trim. Here, VC1 is your antenna trimmer. So L1, let me see here, L1 to L4. This is L1 back here, which we don't touch because we already adjusted it. L2, 3, and 4. These are L2, 3, and 4. So we're going to adjust these on the bands B, C, and D. And I believe we do that at the low end. I'm not sure. Band B, and we're going to go to 1.7 again. There we go. Turn it down a bit. L2. it was already peaked. Okay, good enough. Four megahertz. Yowzers. Okay, that's what the antenna trim does. Brings it right in. Okay, next we'll do band C. Switch it to 5 megahertz. Okay, we'll adjust the trimmer, or the coil. This is L3. It was already peaked. No gains. Let's go to band D, and we will check 14 megahertz. And we'll adjust L4. There's no adjustment. It doesn't make any difference. I might not. Hang on a second here. I need to do L4 from the bottom because the slug is so down far. So there is L4 right here. Okay, it was already peaked. So yeah, so no gains on those ones. So there it is, alignment's complete. It was, it really woke it up. I like the accuracy, I like the sensitivity, and I like the selectivity. They're all three of those are very good on this receiver. Once it's tuned in. It wasn't like that when I first started playing with it though. But as you saw, we brought in a lot of... Turn the lights off here. Got no antenna. Let's see if I can pick something up from down in my dungeon. Just with a piece of wire. Well, there's our friend WWV Time at 15 megahertz. Picking this up just with about a 3-foot long chunk of wire, and I'm in the basement, so that tells you how sensitive this thing is. But I think what I'm going to do for a demonstration, I'm going to get a proper antenna set up. I don't have any antennas here on my property, but I can stretch out a long wire just for the test. And we'll hook it up and we'll see what we can pick up, because this thing just itching to just go across the bands and find stuff. It's just barely there in the noise. kind of fading away now. And it's 3 in the afternoon, probably not a very good time to be doing. What is that? So it is working, and it works well. I'm really impressed. It's a good receiver when it's tuned up. When it's not tuned up, it was average, so-so. But I think what I did with the alignment, it helped a lot. So let's get this outside and let's test it.